Hi, my name is John Breslin from NUI Galway, the National University of Ireland Galway, and I'm going to be giving you this video series of lectures on the fundamentals of electrical and electronic engineering. So a good place to start is, well, what is electrical or electronic engineering, or EEE for short, and why do we need it? So there's a variety of definitions of what's electrical and what's electronic. Some people often consider electrical to be the exact same as electronic engineering, that they are interchangeable terms. Others consider that electronic engineering is perhaps a subset of electrical engineering. Here's two definitions that I particularly find useful. One is thinking of electrical engineering in terms of how electricity or electrical power is transmitted and utilized and brought from one place to another. That includes things like power transmission, electrical machines, power electronics, and so on. In terms of electronic engineering, we can think of how electricity is being used to process information, to communicate information, to bring it from one place to another. And that includes things like communication systems in terms of radio and TV and so on, computers, and obviously things like microprocessors, integrated circuits within those computers, and the various systems in those that enable the transfer of information from one place to another. I'm not sure if you've seen this TV show, but it's called Revolution, and it kind of imagines a future where electricity has basically been wiped out by some kind of global catastrophe. And it imagines, I suppose, a world where life is quite changed by this lack of electricity. So it's an interesting thought, and indeed, in relation to this course, I'm trying to see if you can imagine a world without any electrical or electronic systems. So we can think of, obviously, the impact that would have on mass communication in terms of having no radio or no TV, or internet connectivity, as we've become so used to now. No telephones, whether they are landlines or mobile. Also in terms of things like buildings, we can't maybe build the buildings as easily. We don't have cranes, we don't have the various construction systems are used to create these buildings. But then if we actually had a building, well, we couldn't even have a electrical lift to go from the top to the bottom. We would have difficulties with air conditioning, with getting around the building, I suppose. And then on smaller scale, we think of things like computers, tablets, video games, and so on. So more fundamentally, I suppose, it's difficult to imagine how we could be without electricity, without the power that kind of powers all the things we use all the time, our lights in our homes, the lights on the streets, and so on. The variety of electronic devices we've become used to, from our watches to our clocks. I suppose more importantly, in terms of medical technology and things that are vital to survival in hospitals, like ECGs, heart systems, and so on. And then, of course, the stuff we're used to in our houses, like our fridges, our freezers, our washing machines, and so on. And then in terms of how we get from one place to another, so the traffic control systems that allow us to navigate with our cars, the cars themselves, which are powered by electricity and increasingly by electronic systems, trains, planes, the whole navigation systems, the radars, and so on, that allow us to basically get around more easily than we used to be able to before. So I think you'll probably agree that if you imagine such a world, it would be pretty primitive. It would be very difficult for us to survive in it, and I suppose ultimately it would be very hard for us to live in, given all those things, or the absence of all those things. So maybe just for a minute, you could try and think of three of the most important electric or electronic technologies that have improved quality of life for us here. And it could be a variety of things. It could be something that is so pervasive that you just can't imagine life without it. It could be something you carry on your person. It could be maybe something you use more frequently, something that's maybe just once in a year, that is actually vital to how you actually live, or how many people could actually survive. So it's interesting actually to see where electricity and electronics came from, and it's actually a story that goes back quite a long time. I was surprised when I started researching this, actually how far back electricity goes. electricity is often strongly tied to magnetism, and they are, in fact, very interrelated. So it's actually interesting that the earliest story of electricity or electromagnetism goes back to the 3rd millennium BC. So it's a story that's recorded which is about the Yellow Emperor of China, a person called Huang Di, who basically was in a battle with his enemies. And according to the story, he had what was called a south-pointing chariot. And this south-pointing chariot allowed him to find his way out of a miasma that was basically enveloping him and his enemies. And indeed, through the use of this south-pointing chariot, he managed to escape the fog and eventually win the battle. Going forward in time to the 500s BC, in Greece, Thales found that if he rubbed the material amber with some soft cloth, that it in turn attracted small bits of straw. So this was, I suppose, one of the first recorded discoveries of static electricity, and indeed it was followed up later on by a number of scientists in the 1500s and 1600s. And hopping right forward nearly 2,000 years to the 1700s, we have two people who I suppose were doing related work to follow on from the discoveries of people around the idea of static electricity and certain materials attracting items. And one of those was Stephen Gray from England, who described the idea of having conducting and insulating materials. So some materials were good for conducting electricity, and other ones were not. And indeed, across the channel in France, Charles Dufay found that charges repelled, and unlike ones attracted each other. This is a picture which you might not have seen before, but you've probably seen some kind of variant on it, and it's a picture of one of the founding fathers of the US, Benjamin Franklin. And as you may know, Franklin had this theory that the electricity that was in lightning in the sky was very similar to the electricity that people were encountering. And he basically did an experiment where he had a kite tied to a key, and he was trying to draw electricity from the sky. And then, of course, we had people like Galvani and Volta, and they had a famous rivalry to try and discover the nature of electricity. Galvani had a experiment where basically he was able to make a pair of frogs' legs jump by connecting a metal connection between one end of the legs and the other end. And he posited that this was a kind of form of inherent animal electricity that was actually within the frog's legs. Volta, on the other hand, felt that there was another reason for this, and he went and tried to reconstruct or redo the experiment in a very similar manner, but without the presence of any kind of animal material connecting the two sides. And I believe he tried a couple of different materials before eventually he created what was called the voltaic pile. And the voltaic pile was basically very similar to a battery, and indeed he was able to replicate the effect that Galvani had shown in the frog's legs, and showed that it wasn't some kind of animal electricity, but rather this phenomenon could be created through an artificial means. And the voltaic pile and of course voltage are all named after Alessandro Volta. So then, hopping forward again to the 1800s, we had a variety of people who were discovering relationships between electricity and magnetism. So we had Ørsted, Faraday, and Henry all finding at different times that either magnetism or a magnetic field could be used to create an electric current, or in the reverse direction, that an electric current basically created a magnetic field around it. Also, soon after, we had discoveries by a variety of people in terms of how electricity behaves and how it's related to current, how current actually behaves in a circuit, resistance and its relationship to current and voltage were all discovered by the likes of Ampere, Ohm, Gauss, Lenz, and Kirchhoff. So then, I suppose the applications of electricity, one of these would be quite well known, which is the telegraph. And indeed, although the telegraph has gone by the wayside, it was quite a long-lived technology. In fact, up to 30, 40 years ago, the telegraph was still quite popular. But its story goes back to 1837. And indeed, another interesting story and a sad story about Samuel Morse. So Samuel Morse wasn't an inventor, but he experienced a tragedy in his life in that he received a letter from someone informing him that his wife was quite ill. And by the time the letter arrived to him, and by the time he actually was able to go and return home, his wife had unfortunately died. He afterwards devoted his life to try and understand other ways of communicating more quickly. And it was through a meeting with somebody who was working in the area of electromagnetism that he went on to study and derive the idea of a telegraph. And indeed, he created the first successful electric telegraph in 1837. Going on from that, again, back to the theory, Maxwell was a person who came up with some very famous laws governing electricity and magnetism, and he also deduced that the waves in electromagnetism were basically traveling at the speed of light. It was actually realized then later on by Heinrich Hertz, who was a German physicist who actually went and produced such waves. This is a great picture. It's one of Nikola Tesla, and it's actually a multi-exposure picture. Tesla was a fantastic inventor and also very effective at publicizing his work. He actually worked for Edison, and we know Edison, of course, as the inventor of the long life light bulb, and also very much associated with things like the record player, with motion picture cameras and so on. Tesla had a very big impact on our lives because he was one of the developers of the first modern AC supply systems, which bring electricity to our homes, and also of the AC induction motor. Another interesting story is that of Alexander Graham Bell. We often think of Bell as being the person who made the first phone call, and indeed that phone call happened in March 1876. What's also interesting is that he was also a very astute business person, and he also had a good team of lawyers. And in fact, he and another person called Elisha Gray basically submitted a patent for the telephone on the exact same day. I believe it was in February 1876. Because of Bell's superior business savvy, and also the fact that he had I suppose a good team working with him, he actually is I suppose remembered, whereas Elisha Gray is not. And of course there was a variety of discoveries, not just by Bell but by the company that Bell founded afterwards, as we'll see. NUI Galway has a nice connection to the story of electricity and electronics, and that is due to an Anglo-Irish professor called George Johnston Stoney. Stoney was a professor at NUI Galway from 1852 to 1857, when it was called Queen's College Galway. And he went on to work in various roles in the Irish state. And during that time he came up with the theory that current consisted of small particles which he termed electrons, and indeed he's the person who we attribute the name or the term electron to. I think this is fascinating when we think of how pervasive electronics and the word electron has become in our everyday usage through email and so on. And of course, if you Google for email, you'll find, tens of billions of results, and the same for electronic. There will be billions of results for that term, stemming back to Stoney. Vacuum tubes came soon after in the 1900s. It was found that an atom traveling from one end of a vacuum tube to the other could actually detect the presence of radio signals, and indeed later on vacuum tubes were created that would actually allow you to amplify these signals. And of course this led to the development of not just radio but also of radar systems and of television. Another Irish connection to the story is in the form of Marconi, who was an Italian inventor but who had Irish heritage. As you may know, Marconi was very active in the area of radio communications, and then he sent the first radio transmission from the UK to Canada. And later on, he set up a number of radio stations, radio transmission stations around the world. This picture here is from nearby us here in Galway. It's from Clifton, which is west of Galway. And indeed, this is one of the stations that was used to communicate with Canada and also with the UK. This is another great picture. It's of one of the first general purpose computers, what was called the ENIAC. And you saw the vacuum tube we had earlier on. This computer was built from 17,000 of those vacuum tubes. Indeed, a real feat of engineering in that it had not just all of these vacuum tubes, but also tens of thousands of other components, including resistors, capacitors, switches, and some absurd amount of hand soldered connections. While it was a very important development in terms of being the first general purpose computer, because most of the other computers before that were specific to some kind of purpose, it suffered from, I suppose, issues with the vacuum tubes in terms of if one blew, there was quite a lot of work in terms of how you figured out which one was gone and how to fix it. Going forward in time to the 40s, after the World War, we have the transistor, which was invented in Bell Labs. So we mentioned Bell earlier on, and transistor is such a hugely important step in the world of electronics. This is a replica of the first transistor created by Bardeen, Britton, and Shockley. And indeed, transistors were the fundamental component of what we call integrated circuits, which are basically groupings of transistors that are used to perform certain logical operations. The integrated circuit was built by Texas Instruments' Kilby and his team, and indeed I think one of the most fascinating implementations of integrated circuits from the 60s is this thing. This is the Apollo guidance computer, and of course this was the system that was used in the moon landings. It was basically their onboard computer, which consisted of 4,000 logic gates, which in turn would have had a variety of transistors used to implement that computer logic. So hopping forward then to the 70s, we had the first commercial microprocessors. So these are the first microprocessors that could be used to power things like computing systems. Two important ones. One that was created by Ted Hoff, the Intel 4004 and his team, and also the Texas Instruments TMS 1000. Another great story of rivalry is that of Martin Cooper of Motorola. Here's Martin from a picture from 5 years ago, and he is credited as being the inventor of the mobile phone, and he made the first mobile phone call to Joel Engel of Bell Labs. So I can imagine that must have been an interesting call when he picked up his mobile phone and made the first call to his rival. And indeed, another interesting step is the development of the smartphone. And here is a picture of the iPhone, as Steve Jobs said, an iPod, a phone, and an internet communicator all rolled up in one device.